there's been some quite interesting things that have happened since we talked last. Okay. Let me get myself in trouble by dropping some names here. Okay. So there's this guy, maybe you've heard of him, Francis Collins, head of the NIH.
What is it? It's
Francis Collins, head of the National Institutes of Health. Okay, he's super famous. Okay, so he and the NIH have been having brain initiative meetings. So there's the Obama Brain Initiative.
Yeah.
That was funded for 5 years, and now there's another 5 years of funding. Anyway, long story short, in the first 5 years, Connectomics really did show that it could help neuroscience. There are examples of from our lab and collaborators doing a whole half of a fruit fly brain, tracing out the connectivity along with Google, the automated segmentation connectivity, just revolutionizing our understanding of this model organism. And other examples from Allen Institute doing a cubic millimeter, Harvard doing cubic millimeters. There have been a lot of good scientific results on the connectomic side, so much so that there is a push now within the NIH to fund a whole mouse brain connectome.
That's amazing.
It is getting funded. It is getting funded. Okay, it is the.
You didn't lead with that. You didn't lead with that. This is amazing news.
Exactly, it is amazing news. Okay, and I don't want to, God help us, because I don't want to torpedo that by saying that it might be relevant to humanity in some way. Let me be a regular neuroscientist and say, we might learn something about the mouse brain from this project, but I want to be very clear to anybody who's scared that we still don't understand anything about how the brain works, and we never will, so we're not going to frighten you in any way. Okay, that's kind of the standard speech of a neuroscientist. But the fact of the matter is, my God, we are getting there. We are understanding how memory is encoded. We're understanding how the mind works, and we're even at the level of the NIH is starting to really accept the idea that getting a whole mouse connectome is something that we can do in 10 years. It is ambitious, and it is $1 billion probably prospect, but they are literally considering this. And so, and again, I'm just like a little tiny drop in the bucket on this. There are big labs, Harvard.
You're not getting $1 billion. You're not getting $1 billion. You mean you're not getting the $1 billion?
No, but I have to to toot my horn a little bit. Some of the technology that I've been developed in is that I've been part of developing. Those techniques are the ones that are being considered for being able to do a whole mouse connectome. Okay, and there's a reason for it, right? Because to even contemplate doing a whole mouse brain connectome, you have to develop really new techniques, and this includes these multi-beam electron microscopes, and it includes, I think, probably thick sectioning and broad ion beam milling. This is so I think I've gone off on a tangent a little bit, but
no, but it's an interesting time. I mean, look, it's funny, like this is really exciting. I mean, if I'd have told you that was even being considered a couple of years ago when we spoke, you'd have been like over the moon.
Yeah, absolutely.
But you said anyway.
It's a real thing, and it's a real thing for good science purpose. Okay, it is. There was one of the scientists I was listening to one of these meetings that where the scientists were proposing this to Francis Collins and the group, and they were saying there's you know, it's like neuroscience can be considered before connectomics and after connectomics. You know, before connectomics, we didn't know what the circuits looked like at a fine-grained level, and so how are we supposed to really understand what they were doing? And after connectomics, my God, we really see the circuit. At least we have a fighting chance at understanding it. This is not saying that we understand all of the neuroscience or something, but it's saying that our techniques have reached a level that that we can think about doing this. Let me bring this back to brain preservation. So I was at one of these meetings, and I was too scared to say anything. Okay, I mean, it's like these people are just so beyond me.
These are your fellow scientists, right?
These are my fellow scientists, absolutely. I was at the brain.
These are people that you admire,
well,
but they're not beyond you.
Well, yeah. So these are they run their own labs. They're at a higher level than me. They're at a much higher level than me. So I always you know, take what I'm thinking and kind of put it in perspective of, you know, well, who am I to say any of this stuff? But you know, I'm at this meeting, and you know, they are very, you know, these are the people that are smarter than me, and they are saying, you know, we think that doing a whole mouse brain connectome is something that could be achievable in 10 years. And it would revolutionize neuroscience, and we should go for it. And they even had people in the audience that didn't know what they were talking about, apparently, saying, "Why don't you do this with a human?" And they had to walk them back and say, "Look, that's just you know,
you must have been like."
And I think Francis Collins said something like, "Look, you know, the technology is not there. It's probably going to be 50 years or something before we'll be able to do this with a human."
And Francis Collins is a neuroscientist who runs his own lab.
Head of the NIH.
Oh, he's head of the NIH.
Head of the NIH. Okay. He's Dr. Fauci's boss. Okay. He was instrumental in the Human Genome Project. You know, enough said. Okay.
That's a big one. Okay.
Yeah.
So, but in the NIH, and again, I wonder, because you probably have a sense of it, and it's one of these things that I've wondered about. So everybody wants to get one of these grants for something that they're working on. They apply for grants, and you hopefully get one of these sorts of meetings that you attended with Francis Collins, where you get to, I imagine. And then how does it work? What is the process where they then greenlight the money? And I mean, give me a sort of sense of it.
Well, you're talking to somebody that probably doesn't know the process, right? Because again, I'm just a little.
Yeah, but you know more than me. You probably know more than
the game here, right? I go into the laboratory, I build my little electron microscope stuff, and hope that somebody else finds it useful. Okay, that's where I am. Okay.
You're being overly humble or overly because I mean, look, it's like me. You asking me like how films are distributed. I'm like, I'm not a film distributor, but I can give you a sense of like, oh, these are the different.
Yeah. So I mean, this is a humongous project. Okay, this is not the kind of regular grant that somebody goes and tries to get. This is the kind of you know, the Obama Brain Initiative had a whole bunch of funding that Congress put forward, bipartisan, to fund things that would really revolutionize our understanding of the brain. And so they look at all sorts of different techniques that could not be just little one-off techniques and one-off labs, but would be something that would really revolutionize the field as a whole. So for example, I think a good analogy is a space telescope, right? You know, if somebody's an astronomer and they're proposing seeing something, you know, doing some observation time, that's one thing. But if you're talking about spending $1 billion on something that would help the entire astronomical community, then you start to say, look, do we want a space telescope? Do we want, you know, some of these other ground-based telescopes? We want something that has many, many purposes. And so the Obama Brain Initiative was designed to fund those types of things that would help hundreds, thousands of neuroscience labs in their day-to-day work. And that's why this is even being considered. This is being considered from a purely we don't have a good enough anatomical details of a mammalian system. We're getting that in systems like fruit fly and stuff now, but we don't have a good enough anatomical fine-grained understanding of the anatomy of the connectivity of the brain to answer all of these different questions of all these different labs. If we pooled our funding, could we get a full mouse brain connectome? And it is right on the edge of being impossible with today's technology. In fact, it is impossible with today's technology. There would be a lot of development to even get to that.
But your fruit fly electron microscopes are, if not there is the 2.0 that you're developing that is being considered to be part of this. That's the sort of, in a nutshell, way.
I mean, it's not in the same funding batch. That's certainly true. The fruit fly work is different funding. Okay, but the fruit fly electron microscope connectomes that have come out in the last few years, some from our group, some from others, have really showed that that it's possible at this scale to get connectivity of a whole large parts of an organism, and we're shooting for a whole Drosophila. That's what that's what I spend my days banging my head against the wall on. It's to get the entire central nervous system of a Drosophila, of a fruit fly. Let me go back to that. So I'm sitting in the audience. Again, I'm a pawn or something, okay? But I'm sitting in the audience and I'm thinking, here is the National Institutes of Health that is seriously considering that that within 10 years we could have a whole mouse brain connectome, and they are very clearly saying we're not going to have a whole human brain connectome because that's going to be technology that may take 50 years. Okay, they are saying that this would be useful because it would allow us to read off the kind of algorithms of the brain, and yet even at that level, okay, so I'm saying that there's a buy-in at that level that even with in 2020 this is being contemplated, and yet if somebody extrapolates this and says in 300 years we're not going to be able to upload people, that seems it seems like a complete disconnect. It seems like a disconnect. It's like and even if they say that, it's like the techniques. I mean, it gets worse. It gets worse, right? The techniques that this mouse brain would undergo to prepare it for this electron microscopy are the techniques that are being proposed to preserve human brains. Okay, this is the first step in the procedure that we already know works because we're already saying we're going to be able to get a whole connectome of a mouse brain. There is a willful lack of connecting dots here.
Well, it's not even imagination. I think. Look, we're back to the same place of like, they don't want to. They don't want to use it's not even imagination. It's not even creativity. I think it, like we said before, this is a cultural thing. Look, and I think maybe it's also political. I can't imagine that a job at the NIH in some ways isn't political. And I mean, even somebody like this guy, who obviously there was a lot of pushback, if I recall, with Craig Venter's project. At least culturally, and so I mean. Probably not the same, but there was certainly this sort of very conservative undertones. So look, this is, I mean, it's funny because you did seem so angry and frustrated at all of these things. But actually, if I pull myself back in looking at what's happening, I don't know your ins and outs of some of the personal stuff that's going on, but in terms of the professional stuff and in terms of it making it more likely that you can pull this off, not on your time frame, but it's never on any of our time frames. I mean, it sounds a lot more hopeful than it did 2 years ago in San Francisco.
If somebody like, I want to explain how close this is, right? It's like, so if somebody like Francis Collins, or somebody like, name half a dozen famous neuroscientists, if somebody like them that knows what I'm saying is right, okay, they can call me up and tell me I'm wrong. Please do. Please explain to me why I'm wrong. You know, sit me down like a little child and explain to me why I'm wrong about this. Okay. But if I haven't heard it and I've been asking for a while. Okay. So if somebody at that level decided tomorrow, you know, I'm going to advocate for this. I am going to use my position to advocate for, and I use the NIH as an example because the NIH it's not a brain institute, right? It is a helping humans, suffering humans, okay? I am pissed off at the NIH because people are dying, okay? And there's a technology that's right in front of them that could save people's lives, and they're not using it. They're not developing, they're not looking into it. They're just saying, oh, that's science fiction, who cares? Okay, I'm not going to talk about it. It's wacky. Okay, but it isn't, and because I haven't heard any good arguments against it. Okay, that's my problem. Okay, so what I'm saying is that if we broke through to just even maybe one of these high-profile people within the scientific community and got them to actually advocate for this, the world could change. In 10 years, it could be at every hospital. You could have this option at every hospital. If one person at Francis Collins' level, or one person at Eric Kandel's level, or one person at even Ed Boyden's level, okay? So there are plenty of neuroscientists who know what I'm talking about and are silent about this because they're fearful of their career. Oh my God, is this where we are? We're fearful of our career, and so we're going to let torture and suffering and death rule for another, how long? Who knows how long? Decades and decades and decades, until there's this mythical proof that already exists. It already exists. You know, I don't know. I'm frustrated. I'm sorry.
Well, yeah, look, I mean, it's funny because I'm sure that there are many scientists before you. I'm not sure if probably even neuroscientists, probably very likely in the neuroscience side there, frustrated neuroscientists, but, you know, who've had these same, not exactly the same, but these ideas, which again takes lots of banging heads. I mean, and the thing that occurs to me is, you know, scientists, they may run their domain or run their sort of dominion in these terms, but they also answer to certain people. I mean, there are these big benefactors.
You know, oh, if we had an experiment that showed that memories were actually stored at synapses. I've actually heard people say this. Like, what? Have you paying attention for like your basic neuroscience class? Okay, I can give you. I have a list of like 100 quotes from papers that I give to people that say, okay, look, if you think that there's not a consensus about how memories are stored in the brain, you know, here is the consensus. Okay, so in any case, it's. I mean, I hear what you're saying. You know, I think this is a scientific question. These rich people are not neuroscientists. If this is a scientific debate.
The debate is scientific, but the actual pushback, because the debate you're getting from every piece of evidence that you're presenting, is that the debate doesn't become about science. It becomes about something else. And so you need different weaponry. You need a different line of attack, because people, you know.
Well, I don't want. I don't want the type of buy-in that religion has. Okay, I mean, there's plenty of people that buy religion without any evidence because they just want to accept it. Okay, that's and actually, you know, you could turn something like this into a religion, get a bunch of people behind it. You know, I think to a certain extent, I'm going to get in trouble for saying this, but I think to a certain extent, cryonics is dabbling on that line, because let me say something really controversial. I know you like it when I say stuff that's really controversial, right? Okay, so there are people that it's like if it doesn't matter to you how good your preservation, if you don't want to know how well your brain is being preserved, then that's probably a good sign that that what you're getting out of this is just the kind of good feeling that you get from a religion. I mean, a religion is saying, "Oh, you're going to go to heaven. You're going to go to heaven," and you know, people that are religious, they should not think too hard about that you know, evidence and what that would mean. They shouldn't think about that, because that will take away the kind of good feeling that they're getting. Okay, the more you think about it, the less good feeling that you're going to get. And it seems like chronicists are kind of in that in that modality. You know, the run-of-the-mill chronicist does not want to hear how bad their preservation is going to be, and they don't want to. Apparently, they don't want to hear that there's better techniques that can be that can preserve your brain much better, because that messes with the whole thought of, oh, you're just gonna walk off the table like Austin Powers, right? You know, so if you're trying to ignore reality, then it's the religion. Okay, and so you know, I think it is still a scientific debate because scientists are the only ones that are going to get this at an initial level, right?
Well, when I say it's not a science, I think the debate with scientists devolves to almost from what you're saying, almost not quite religious, but some sort of moral argument that prevents them in public from saying, actually, you're right. In theory, these pieces, from a neuroscience perspective, I mean, you showed me, I remember reading all the textbooks where there was this textbook and that, and yet those same people, when you cornered them. So you're having a scientific debate with scientists who aren't approaching this completely as scientists for whatever reason. I mean, that's what it sounds like.
Because I think that they are living in the same world that we are living in. Okay, so at a abstract level, scientists would see what I'm saying. Okay, but from a societal level, a scientist that pokes their head up and says, "Oh, you know, mind uploading is going to happen. We have a technique that that can preserve brains good enough for to be almost certain that mind uploading technique would work on that preserved brain, and so therefore we should put it into hospitals." They would get whacked off by society. They would get their head whacked off by society. And they realized that they would get their head whacked off by society, and they would probably get their head whacked off by their colleagues that are also concerned about what the societal impact would be on them. But at the same time, they're the ones that are really, truly committed to the idea that the brain is what we are. It can't be disconnected. It's your random person in the street can totally object to this. Totally object to this, because where is the soul? You can't have a machine that's conscious. I just don't understand this. There's a magic of biology that you're losing. Memories are part of the soul. What are you talking about? There's you know, what about individuality? You can't copy a soul, because the soul is not just information. All of these things the random person in the street are going to say, and they're going to believe. Okay, but the neuroscience community, they're committed, hopefully, to all that we've learned about the brain for the last 100 years, which sums up to that we really are computation in the brain, that our memories really are encoded in the structures and molecules that are being preserved by this technique, and that hopefully they're committed to the idea that neuroscience is on a path, a very slow, painstaking path that will probably take a couple hundred more years to get to final, complete understanding of how the brain works at a computational level, and the technology needed to upload people.
You know, as you were saying, it's funny, like I was thinking, maybe it's also this idea that we are just zeros and ones, that all of it, all of this stuff that we experience, that we perceive, that we taste, that we smell, that we hear, all of it, it's just zeros and ones. It doesn't seem very sexy, but that's what it is. We're just like these algorithms and these equations, and I think, I don't know, I mean, I think that's part of it. I do. I mean, I think it's that you've got all these things that hundreds of years. Oh, are we really just these little equations? I mean, I don't know. I'm just thinking. So I was in the film. A lot of people have said to me, got upset with me that, oh, why did you choose cryonics as opposed to? Well, I didn't choose it. Number one, this was the thing that was available to FM at the time. I think he would have been. And to me, it wasn't about the method. It was about there's going to be some method, hopefully good, hopefully thought out, hopefully with good people, and so it wasn't about it. But so many people get so specific. I mean, and again, I don't need to be specific. I'm not a scientist. I can be, you know, I don't know, metaphorical or representational or something. I mean, so I don't know that there's a particular question there, except that it wasn't that I was, and I remember Aubrey, and it's funny because I think Aubrey's really smart, and he's actually really like a lovely, good person as well. But he also was like, you know, this is cryonics. I'm like, but Aubrey, this isn't, to me, it wasn't about that. It's about, there's going to be a method, whether that's, you know, copying the connectome in you know, with that particular method, or whether it's some other method, it doesn't matter. I mean, we've got, like you said, this terrible problem. That sounds so English and understated. Yeah, we've got this terrible problem called death, you know, death and torture and horribleness. Yeah, the troubles, yeah, exactly. The troubles still crack me up to this day. It's like, yeah, just like people losing their legs and like next door in the bomb, the troubles. It's just so English in that sort of cavalier way, where it was actually funny. It was there was somebody on the BBC yesterday talking about Winston Churchill, which always, because Winston Churchill always has this sort of being this amazing person, brilliant, funny, satiric, but you know, really bad, brilliant. He was a terrible tyrant and killer, starved millions and millions of people to death. But it was just funny to hear for the first time somebody in India saying yesterday, I don't know, some minister, they want to take down some statue of Winston Churchill, and I'm like, of course. I mean, there's nobody who's killed more Indians. The Pakistan, nobody that killed more Indians than Winston Churchill. I don't know why I'm saying this, except for the fact that you're going to have a lot of perspective. I mean, I can look at where you're at. I haven't spoken to you for 2 years, and think, wow, shit, like so many things have happened that are good, that put you in a better position. Now, with you and your goal, until you have the NIH say we're doing our first human brain, you're going to be frustrated.
All the connectome projects in the world are not going to add up to the type of social change that I'm talking about. You know, I mean, let me restate this, because I just think I think I need to restate exactly what I want. I want the medical and scientific community to develop a brain preservation procedure and deploy it in hospitals in a regulated manner to make it available to terminal patients as a choice. That's it. That's what I'm looking for. It's not a it's not a big thing if you really think about it. It could be slid in as a it's a small,
like an organ donation. It could be like you tick a box and it's like with the organ donation.
Well, I'm not even saying that. I'm saying that from a developing a new vaccine would be much more expensive. Developing a new heart procedure would be much more expensive. Hell, doing a connectome of a mouse brain would be way more expensive. Deployment of a medical brain preservation procedure in hospitals.
Why would the mouse brain be more? Because you then have to actually not. Why? Because you then have to image it.
It's exactly. I mean, the technology, the technology for preserving brains is vastly easier to accomplish than the technology to bring people back.
So it's stable, and you've shown that the structures are retained, etc. That's all been shown, documented, etc.
Yeah.
The question is, and that's relatively inexpensive to put in place, to actually do that. It's the piece, and this is the piece that I think gets sort of lost. There are various steps that we don't know how to do, but the first of which would be to actually see it, for it to have a three-dimensional representation of those structures so that it can be brought back. And that's the expensive piece. That's the piece that's expensive in terms of, is that wrong? I just want to make sure.
It's not just expensive, it's completely impossible for the next 50, 100 years. Okay,
but did I miss any steps in that? Because I just want to make the distinction between the preservation, the imaging, and then the uploading, because the imaging isn't just, it's not one and the same.
The medical procedure is something that could be very straightforwardly developed at low cost and deployed in hospitals. There are plenty of checks that can be put on top of it, that taking biopsy samples and doing small scale imaging to make sure that you preserve the synaptic structure, doing X-ray scans of the brain as it's being perfused to make sure that you're getting the perfusion correct. There's plenty of things that are absolutely existing technology that could make a brain preservation, a regulated brain preservation procedure in hospitals for terminal patients deployable and reliable, and that should just be done. And I guess what I'm saying beyond that is there is a gulf between deploying that and any type of real revival. And if people are looking for real revival, you've got to accept the idea that if you are demanding real revival or real proof of revival, even if you're talking about a mouse, okay? If you're talking about real revival proof, you're condemning 100 years of people to die for that proof. And that's stupid, so don't do it. Okay? Come up with more reasonable evidence that can be gotten, that can get the same level of scientific rigor to saying how good the preservation is and what we need, side experiments on how memories are encoded, anything you want, okay? But don't demand this, we're not going to think about it until the first person walks off the table as an upload, because if that's the case, you're condemning 100 years of people to die meaninglessly. And in retrospect, the people of that future will understand that you killed all those people. That you, as a knowledgeable neuroscientist who knew what was possible today, you decided to go and let those people die, even though you knew that there was a technology to preserve their brains, and that the technology would likely come around that could revive them. And you have this, for some reason that I would like you to articulate, okay, in public, in a debate with me, let's say, okay, explain to me in public, in a debate, why you think a terminal patient should not have this choice. Why I, when I become a terminal patient, knowing what I know, don't have the knowledgeable consent to give to have my brain preserved. Why are you telling me that I need to go to a grave as opposed to a preservation procedure? And please do it in public so everybody can hear, and you can wipe the floor with me.
We will try and arrange that. We'll try and get that going.
Okay.
We'll try to get that going.
Sorry, I told you I was animated today.
Good, animated's good. So, did you like the film? It's different.
It was very different. It was odd seeing you as an actor in the film. I could feel your pain.
Yeah, it was very painful. It was very painful. I mean, which look, I wanted people to ask the sorts of questions that you generally ask in science fiction, but you don't really ask. You don't really ask questions in science fiction. It doesn't have the same palpability as realizing, like, look, it's like all these things are going to happen, and how they happen, in what capacity they happen, who makes them happen, are there going to be regulations? I mean, some of the things that you've talked about, informed consent, I mean, all these things, we need to have conversations about them, not just this. I mean, there are so many pieces of all of this that I think, I mean, you know, I mean, there are so many, even when you do something that has all these attractive, beneficial qualities, there are so many unintended consequences unless there are discussions, and not just discussions with the powers that be, but cultural discussions. I mean, that was really why, to sort of, I think it's important.
Let me ask you a question. I like your movie to the extent I like science fiction in general, and I withhold my disbelief, you know, in stuff. But I prefer 2000 Odyssey to Star Wars. Okay, I don't even know if I do that. I mean, it's but in any case, I really like the 2001: A Space Odyssey movies, or The Martian, and stuff like that. That are really, they try to hold absolutely as much as they can to the science. And I've never seen an upload film that actually holds anywhere close to the science. And is it possible that a movie could be done that way? Because, you know,
as close to the science. Yeah, I mean, it's like you said. It's like, I mean, if you do something that's as close to the science as you can be, especially if it's a science, as sort of fantastical science, or, you know, you keep all those things. Look, I tried to get all sorts of people to give us, to be scientific. We didn't have much money, so to give us sort of scientific advice. I think the thing that you have that is hard is what you say is you then have all these things that are not they maybe this technology that does this one thing in terms of the plot. Oh, it brings this person back. But like you said, then you then have a world where the technology is like they're driving like petrol cars. I mean, so there's all these, you've got to run these same things throughout all the things, and that may give you less conflict. If everybody's happy because at that point you just turn a knob, you don't need no antidepressants, then the piece in the thing about the lunatic uncle who's got off his meds doesn't work. So yes, you can. It just takes a lot more thought to have a sort of through line of the world and the implications of that world, and how does your conflict and your plot work?
The reason why I'm saying this is because I think there's a communications issue about this idea, right? Because I've the video that you did for the BPF, one of those sub videos was me walking through the whole procedure in text, in language, how incredibly difficult it would be to bring somebody back, but kind of a reasonable scientific method to do it, and walking through the very real preservation procedure, and so I've done that in text form, but if people could actually see in movie form what if they could imagine what I think is really going to happen, all the way through the preservation procedure, Roberts, ASC, et cetera, all the way up to how it's stored, how the technology develops, how the first human upload is done. Okay, so the whole idea that there would be one first human upload in maybe 50, 100 years, okay, that is a $100 billion Apollo moonshot type of a project. That is a fascinating story to tell, and it's a story that could be told with the technology of today, extrapolating.
Let's shoot it.
Absolutely. I mean, let's absolutely shoot it.
Yeah. I mean, I think, like I said, I mean, I'm not sure. I mean, that's certainly the sort of thing that's going to help you culturally. I mean, yeah, I mean, people want to see it. People, I mean, you almost were going the bridge.
That's the bridge that I think people need to see. There is a world today where it's easy to preserve people, and there is a world 300 years from now, maybe, where it's easy to revive people. But in between that, there is there's an Apollo moonshot first human upload that would take an enormous amount of real science and engineering and neuroscience knowledge coming together to make this simulation happen. And if people see, oh wow, yeah, I think we will get to that level, and I can see how it's super complicated to get to that level, and it's going to take lots of work and complicated stuff, but they can see it. Then the reach for having that be easy a few hundred years later, I think, is not too far.
Yeah, especially because we have analogies of really complicated things that seemed impossible with a lot of hard work working. I mean, we sit, there obviously accidents, missteps, unintended consequences. But yes, we have. I mean, isn't that the whole of human existence, pretty much?
Exactly. And why can't to get back to this whole mouse brain connectome, why can't people look at this as, again, I can't stress enough that a whole mouse brain connectome is good neuroscience. It's going to lay the groundwork for a lot of other neuroscience experiments. But why can't society look at that whole mouse brain connectome and see it like the initial launching of Sputnik?
Yeah.
And say, we're not just launching Sputnik because we want to do it once and then forget about it. we're not just launching Sputnik because we want to maybe develop radio repeaters in satellites in space. We're launching Sputnik because this is one piece of humanity's journey into space. And humanity's place is colonizing space. And this is just one little step along that line. And it pains me that the neuroscience community cannot look at their own field and see that that yes, we're nowhere close to that right now, but that is our goal. Our goal is a mind uploading future. That's why neuroscientists do what they do. You know, if you're a medical doctor, you're trying to cure diseases, but you're not going to give up after you cure like one disease. You're trying to cure all the freaking diseases. Okay, one of the things happen anytime soon, but that is the grand prospect of why people develop medicine, and nobody's shrinking away from that. So why do neuroscientists have to shrink when saying that they might be successful in a few hundred years, and that humanity's is going to reach a mind uploading future, and it's going to be on the backs of good solid neuroscience research today into freaking fruit flies. Okay, stuff that's boring, but you can't, if you look at it from the perspective of milestones toward this ultimate goal of humanity's mind uploading future, then it is a grand journey that we are taking. As neuroscientists, let's just embrace how cool neuroscience is for humanity.
It is. It sounds very and it is cool. You are a cool neuroscientist. We're going to get you a T-shirt, the cool neuroscientist. How old are your kids? I mean, I just wonder, like, they have a cool dad, but they don't think they have a cool dad.
They do not have a cool dad.
I make films. My kids don't think I'm cool. I'm not in the least bit cool.
13 and 16.
Oh, they're similar to mine. Because mine 15 and 7. Yeah, just like, yeah.
Yeah.
They good. How are they coping have they been okay in all of this?
It's really hard. It's really hard. I mean, I feel like I'm going crazy, and I get to go to work every day. I've been deemed essential at some level, all the way from the beginning, and so I've been able to go into work.
A lot of uncertainty, but we have to get comfortable with all our uncertainty. I think that's the key. Trying to be comfortable in all the uncertainty.
I feel like Robert is the real hero. You know, I mean, he actually developed the damn technique that everybody else said for some reason was impossible to develop. And you know, he should be known. He should be and the thing is that, you know, he was just ripped to shreds in the media for no good reason. It's sad.
People want, you know, it's the same. It's conflict, and look, this stuff. It's either, I don't think there's one or the other. There's not like sort of a middle ground here. Either you're like full on, like this, we got to do this, or no, it's not. Or you're, or you know, I don't think it's sort of any middle ground.
Let me just riff on this for so there was an MIT article that came out, MIT Technology Journal that came out, and it was relatively straightforward in saying, oh, you know, Robert's starting this company that is preserving people's brains. You know, it's proposing to preserve people's brains, and they went around and they asked some neuroscientists if it made sense, and you know, one of the neuroscientists that they asked was Ed Boyden, and because he had a grant with Robert, and that is a moment in time. It is a moment in time where a famous neuroscientist could have changed history. He could have said, yes, I understand what he's doing. Yes, I knew who I was working with. Yes, this is a real possibility of working, and we should not be laughing at this. I am proud to be working with Robert, and I am proud to say that neuroscience is making progress. He could have said something like that, and history may have been changed at that moment. And yet he said, we don't know anything about how the brain works. We have no idea how the brain works. Don't talk to me ever again. And MIT said, we don't have anything to do with Robert. You know, we do not want to be tied to this nonsense. And that's how good people die. So I'm just saying to maybe the neuroscientists that may listen to this at some point, that they probably won't. Well, whatever. Okay.
No,
that you know, when you have the opportunity to, when some media person is asking for your expertise, give your damn expertise, not your opinion, not your philosophical issues or your sociological, oh, it's proper for people to die, and then wrap it up as a scientific opinion. No, give your damn scientific opinion to the journalist that is asking for your scientific opinion. That's all I'm asking.
I'm going to try and do this when I get a bit of, I don't know, free time. I've got free time, but when I have some clear headspace, I'm going to try and do, maybe we do it on a Zoom thing where you get to do some of this debate. I mean, look, we get to talk about all these things that are really big, big, important, life and death and how we're going to live and how we're going to survive and our children and so on and so forth. I think these are important discussions. We'll try.
I would just say that I think, I know a lot of movements come from the ground up, and that's fantastic. And I think this one, I think this one will as well. But I think that existing, established neuroscientists, the ball is in your court. The ball is in your court. If you want to tell the world that neuroscience will never succeed, and so don't worry about it, go ahead and keep on telling the world what you've been telling them, because that's exactly what you've been telling them. I can point out, people that I've worked with that have been gave interviews and said, oh, and we looked at it, we will never understand this, and nobody ever will. And it's like, wow, why are you in neuroscience? My God. But you could also, these neuroscientists could also embrace the incredible stuff that their field is that they've helped build up is likely to get to in a few hundred years, and they just need to do it. I'm just going to put it straight on. It's not the job of an early PhD or postdoc to make this case. It's just not. It's the job of an established neuroscientist or medical doctor to make this case, because this case is not the kind of a case that it's like, oh, if I do this experiment and show this one thing, then I will revolutionize science. It's nothing like that. It's taking existing science that everybody agrees on and just embracing the implications. That's all that is necessary, and that's the kind of stuff that it takes one really high-profile neuroscientist could start the revolution.